All right, next we're going to start talking about the Pythagorean identities. And we are still in section 5.2. I think we're going to be there for a little bit, and that's okay. So the Pythagorean identities, they are things that you're eventually going to memorize, but I want you to be clear about where they come from. So let's say I have triangle A, B, C, right triangle. And I'm going to go ahead and use angle A as my reference angle. I think we can agree. Remember that rule of thumb is to use those lowercase letters to label the sides that are opposite those angles. I think you all would agree that this is true based on the Pythagorean theorem. But what I'm going to do now is connect those to other ways that we could potentially reference those sides. So if I asked you to find the sine of theta or angle A, you would do opposite over the hypotenuse, and that would be A over C. If I asked you to find the cosine of theta or angle A, you would do the adjacent leg over the hypotenuse, so that ends up being B over C. So watch what happens here if I decide to divide each thing in my Pythagorean theorem by C squared. First of all, C squared over C squared on the right just goes to 1. And this first term, A squared over C squared, could also be written as A divided by C quantity squared. We're squaring both the numerator and the denominator. And my second term would be the same as B over C quantity squared. The reason I chose to write those like that is because now these expressions match the expressions that we set up with our trig functions. So what we've just done is we have proven that this Pythagorean identity is true. Sine squared theta plus cosine squared theta equals 1. And remember, we did talk about this briefly before we left for our long break here, that when you see that notation, sine squared theta, that is equivalent to the sine of theta quantity squared. It's just a little shortcut for us to use, and you're going to read it as sine squared theta. It means that take the sine of that angle and then square that quantity. So this is one of the Pythagorean identities. Sine squared plus cosine squared equals 1. Okay, and I'm going to go to a new slide and start talking about how we can manipulate that to come up with some other identities. Okay, I'm going to rewrite it. Okay, so if you don't have this guy in your notes, you want to get it there. That's the first of 3 Pythagorean identities. Next, what I'm going to do is I'm going to take this Pythagorean identity and I'm going to divide that by cosine squared theta. Oops. Sine divided by cosine. Remember, that's another way for us to write tangent. That's tangent squared theta. Cosine divided by cosine, that's just 1. And 1 over cosine, ooh, that is going to be one of those reciprocal trig functions. C goes with S and S goes with C. So that is secant squared theta. Here is a second Pythagorean identity. Okay, and I'm going to switch to a new slide. We're going to do our final Pythagorean identity. This time I'm going to go through and I'm going to divide each term by sine squared theta. Sine divided by sine, that's 1. Cosine divided by sine, well, if tangent is sine over cosine, then cosine over sine is the reciprocal of that, which would be cotangent. So cotangent quantity squared theta. And then on the right side of the equal sign, we have another one of those reciprocal identities. 1 divided by sine, well, S goes with C, C goes with S. That's going to be cosecant squared theta. There is your third Pythagorean identity. And make sure you get all 3 of these in your notes. They're also in our textbook. You can also find them in a simple Google search. and I believe they're in my Trig Bible that I have posted on Schoology. So I'm going to pause for a moment, and I have some examples for you in a different video file, and I'm going to get those up and going for you. All right, here we go. By the way, these identities are in our textbook on page 539. Again, but it's simple Google search, you'll get them too. So here are some examples. I stole these from my slides from our 5-2 lesson that we didn't get quite all the way through. So we'll call that example 1. It says use the Pythagorean identity to find cosine if sine is equal to 7/8. So I'm going to start by setting up our Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. So I'm going to substitute our known value. We know that the sine has a value of 7/8. So when I substitute that, that value will get squared. And I'm going to use subtraction to isolate that. First of all, this, squaring this fraction is 49 over 64 plus cosine squared theta equal to 1. And then if I want to subtract on both sides here, didn't leave myself quite enough room. Okay, so I'm going to subtract that 49 over 64. Cosine squared theta is equal to 1 minus 49 over 64. For me to do that, I would need common denominators. I can rewrite 1 as 64 over 64. And when I do that, cosine squared theta equals 15 over 64. This question asks me to find the value of cosine, so I need to square root on both sides. And when I do that, cosine of theta, square root of 15 is as simple as that gets, but I can simplify the denominator, which is great because then we don't have to do any rationalizing. This is example 2 for this particular video. Use an identity to find the value of the expression without using a calculator. Cosine of 53 degrees and secant of 53 degrees. First of all, when I see these two, those are reciprocal functions. So if I were to rewrite this, cosine of 53 degrees being multiplied by secant, remember that secant is the same as 1 over cosine of 53 degrees. And if you think about multiplying those together, that will simplify to be 1. Next, sine squared of pi over 10, not one of our special spots on the unit circle, so that might be tough for us to figure out without a calculator. But if you notice, both of these angles are the same, so essentially I'm saying sine squared theta plus cosine squared of the same theta, and we know that that thing has a value of 1 according to our identities. Lastly, if we can get through this, this will allow us to finish the 5-2 lesson. This is just simply evaluating using your calculator, so these would be angles that are not any of the special spots on the unit circle. If your angle measure is given in degrees, you need to make sure that your calculator is in degree mode. That one you're probably really used to. You probably don't have a yellow graphing calculator at home, so you're probably either using your cell phone or maybe Desmos or one of those old school calculators, but either way, when I type in tangent of 15 degrees, I'm on my yellow graphing calculator here at home, so I just got to get in the right mode. Tangent of 15 degrees. And they want us to round to 4 decimal places. It has a value of 0.2679949, etc. So 4 decimal places, I would round 2679 and call it good. Okay, and then sine of pi over 5, it is your job to recognize that that's a radian measure. So that is a good time to change that in your calculator. It's going to take me a second, so I'm going to pause real quick. Okay, I had to change my calculator to radian mode. And rounding to 4 decimal places, 0.5878 when we round. Okay, I think that'll get us through 5-2. Again, make sure you're contacting me if you're having any trouble, and we can work through stuff together, okay?